So what we see is when most customers, they start with a DevOps journey, they typically start with Salesforce chain sets. And when most customers, they're evaluating a DevOps solution, they start with a version control system, they start with a deployment engine, with the hope of achieving a higher development velocity, quality releases, and improving developer velocity. But what we see is even with the right tooling, such as a version control or deployment pipeline, most customers are not able to achieve the objectives that they aspire to achieve. And there's a significant gap in achieving those objectives. So what we are going to talk about is what are those gaps and how can those gaps be overcome? So the first is what we see is most customers, when they put a DevOps system, they assume that the information is going to flow smoothly across the entire landscape from the development sandbox all the way into production. But we see that this hardly happens. If you look at the LA freeway system, sorry, I was coughing. If you look at the LA freeway system, when the planners were building the 8 freeway system, 8 lanes on each side of the road, they would not have assumed that there would be a lot of traffic jams. But what we see is commuters are sitting in the traffic every day for at least 45 minutes, and there's a lot of traffic jam in the system. Let's explore what causes this traffic jam and what are the issues to move the information from left to the right. So one of the things that we see is we are going to talk about some of the common issues. So if we start with a topic which is on the left-hand side, here, let's say if you have 3 developers, they are working on 3 features which are completely independent of each other. They have to merge the changes, let's say, into a Git branch, which is, let's say, in this case, is UAT. Even though the features are completely independent of each other, because they are merging into the same branch, they're forced to work with each other. They have to collaborate with each other. Developers spend a lot of time in planning who's going to merge the changes first, who's going to go first. There are ways to overcome this, but if you want to overcome this, that creates a lot of overhead and a lot of work for customers. Secondly, if you look at this picture, if I just want to deploy, if I want to pull out feature 2 and deploy only feature 1 and feature 3, it is a lot of work for the team to do that. It's hard to deploy features out of sequence. It is hard to pull out features at the last minute without creating a lot of work for the team. In case, if we move to the second use case, in case if a feature has been merged and they want to pull out the feature, again, it is hard to demerge the feature from the same branch. And while we see that developers always, they want to keep their branches in sync with the org, it's really, most of the time, it's hard to do it. An admin can always sneak into the UAT org. Let's assume most customers, it's hard to impose all the constraints on the various sandboxes. Someone can always sneak into one of the sandboxes, make a change, and those changes will not be reflected in the branch, causing these things not to be in sync with each other. These are just some of the examples that we see on a very frequent basis. Problem was actually highlighted very well by the previous presenter. He spoke about that Salesforce is different. There are a lot of different metadata issues. There are dependency issues between different component types. But how many of the DevOps solutions today understand the code? And after understanding the code, they take the right corrective action. Wouldn't it be cool if your DevOps system could understand your code, figure out which are the extra components in your code and automatically remove them, figure out which are the missing components and automatically add them, fix API version issues, fix all the metadata issues. And we see most of the time, the deployment doesn't go through, not because of the DevOps challenges, it is because of the problems inherent within the code. And if DevOps systems could have the ability to automatically read the code, automatically fix the code based on users' acceptance of the issues, um, the productivity of developers would be way higher. And if you look at the latest version of Flosum, we correct a lot of the issues automatically with a single click of a button. We recently had a customer who had close to, in one single deployment, they had 22 errors, 2200 errors in the code. With Flosum, within just few minutes, they were able to reduce from 2200 errors to 55 errors. And that was a huge save of productivity for them. The other thing that we see is when developers or when customers, they start using a DevOps system, the number of components in the system increases exponentially. So on the left, I have a diagram where, let's say we just have a couple of orgs, and the end objective is to keep these orgs in sync and have a source of truth so that everyone can build the application from the source of truth. But what we see is with setting up a DevOps system, you don't have 5, 10, 20 branches. You have thousands and thousands of branches over a period of time. All of them have to be kept in sync. Those branches have to be kept in sync with the org. This leads to a lot of branch maintenance work. This leads to a lot of sync issues that customers find it very hard to resolve. Over a period of time, what we see is DevOps increases overhead rather than increasing efficiency. It creates a lot of complexity. And instead of democratizing the whole application development process, it creates silos of environments where only certain people are allowed to touch certain aspects of the system. Otherwise, the system would break. And in spite of all this overhead, what we see is most of the critical issues are not solved elegantly, such as rollbacks, code overrides, merge conflicts. There was a question on the chat where someone asked, they have a very long file with 400,000 lines of code. How do they automatically resolve all those merge conflicts? Those issues which are pertaining to the Salesforce ecosystem need to be resolved. And that is where the solution really has to shine in order to improve developers' productivity. So with that, let's see what is the impact of this. Because developers are forced into a certain process, because of the constraints of the tools they are using, what we see is the development velocity, it gets lowered, quality does not really improve, and business does not see the productivity gains that they are expecting out of a DevOps system. This is where the Flosum solution comes in. We have a very unique architecture. What we have done is, compared to other solutions, we have created what we call as a native repository. The native repository does a bunch of things. First, it very intimately understands the Salesforce architecture, and it understands all the components of the Salesforce ecosystem. So let's say if you have a component that you're deploying and it has a lot of extra components, we'll automatically take care of the dependency issues. If you're missing components, we'll automatically suggest you to add certain components as part of the process. So your velocity of deployment goes really high. We understand Salesforce architecture really well. We understand Salesforce orgs, development sandboxes, Scratch orgs, all the settings, and that is done by the native repository, which is built on the Salesforce platform and completely understands Salesforce. That is one of the advantages of native repository. There is another advantage of the native repository, which is most customers, if you search today on Git branching strategy, you will find millions and millions of blogs. Everyone has their own take of Git branching strategy. The underlying cause is that it puts constraints on customers and takes away the flexibility and the agility that customers want. The native repository provides that flexibility and the agility without sacrificing the velocity that customers need. So with Flosum, you have two deployment approaches. One is you can have a completely Gitless deployment approach. You will not lose any functionality of a DevOps system or a version control, even only if you use the two layers of the Flosum solution. We have many customers, especially the larger customers, for compliance purposes, they have to integrate with Git. So we full provide a complete bi-directional integration with Git as well. The first approach is mainly for low-code developers. You really don't want to use Git, but you really want all the benefits of a version control. The second benefit is for developers, or if you want to integrate with Git for compliance purposes. So this is Flosum's promise. What you would see is Flosum is incredibly fast. If you really want to deploy, right from you start the implementation, you download Flosum for the first time. If you know the steps, you can go from start to finish. You can do your first deployment literally in 15 minutes. To do all the steps in Flosum, such as code overrides, taking care of dependency issues, um, doing rollbacks, you can finish all that from zero all the way in the first 1 hour. If you're doing it for the first time, it may take you 1 or 2 hours, but after that, it's incredibly fast. There are no extra steps that you would have to encounter to move your code from left to the right. It's very powerful. It's built for Salesforce, understands Salesforce architecture really well, understands the code and the metadata of Salesforce really well, and will tell you to take actions to improve your deployment productivity. You can have any kind of branching strategy in Flosum. It's very flexible. You can have all the suggested Git branching strategies within Flosum, minus the constraints that you get because of the interdependency of branches within Git. Flosum is very secure. We never have access to your data. This is why it's used by a lot of financial organizations, many banks, and it's the de facto solution for all the federal agencies such as Navy, Postal Service, Air Force, and so on and so forth. We have customer 5.9. They do deployment. They work in all the 3 time zones. They do 15 plus deployments every single week. With Flosum, they don't see any code override. As soon as the user story gets finished, they push it all the way into production. This is a fantastic story, and we have many, many customers. We have customers who have told us that they have used Flosum more in the first 1 or 2 weeks of the trial compared to using the entire other solution for the entire 1 year while they had that solution. These are some of the architectural differences that we have. We have intelligent merge conflict resolution. So when we merge different components, we have different logic for merging different component types. The way we merge profile options is different than the way we merge aura bundles, which is different than the way we merge Apex classes. We have a lot of intelligence in how we merge components. We can auto-fix a lot of your code issues. We will suggest you that this is how you can fix your code issues. We have override protection. You will not lose any of your code while you're deploying changes. And we have a lot of dynamic pipelines. So you can change. You don't have to be tied into a process. It's good to have a structured process, but there is always a need to break away from your process and deliver the benefits that your business is expecting from you. This is where we have concepts like dynamic pipelines, which will provide the flexibility and the agility that you need. This is another example. We had a customer, they have multiple production orgs. They were spending too much time in merging the code. They were not able to keep things in sync. And with Flosum, they use across Salesforce Cloud, across Viva Cloud, and they dropped Git from the architecture. I'm not suggesting that this is applicable for all customers. You can continue to use Git, but they got all the benefits from Flosum, and they got the velocity and the quality of releases that they wanted. So with that, I'm going to stop and see if there are any questions.
All right, thank you. Yes, there are a couple. So this question is, do you support VPN connectivity to an on-premise Git setup in order to support bidirectional connectivity, or does the Git repository need to be on a public cloud?
It does not have to be on a public cloud. The way the architecture support is created is such that you don't have to make any changes to your Git security settings, but yet we can connect from Flosum to your Git solution.
All right, great. And then we have our next question. How is Flosum able to stop code overwrites?
So we have features within the solution, and most of our customers, so today that feature is optional to use. What we hear from most of our customers is that they want that feature to be mandatorily used before anyone deploys code. We have a feature called as impact analysis. Whenever you're deploying a feature, so let's say if I have my branch, and if I'm going to merge it with another branch, I'm going to see exactly what the impact is going to be before merging the changes. Or if I have a branch that I'm going to deploy to my QA or UAT environment, I'm going to see line by line changes and the impact that's going to cause to each and every component. I have to accept it. Only then you can deploy the changes. So you'll be sure that you have reviewed your code completely and the impact of it before you actually deploy the changes.
Okay.
Earlier, we did not have this feature. We just had the rollback feature. And after we introduced this feature, customers say we never have to do a rollback with Flosum because we never lose code. We exactly know what we are going to deploy and we can see the impact. So that has improved the productivity for a lot of our customers.
Awesome. All right. So next question is, can Flosum take care of managed package configurations like the ones that this person specifically does in Velocity? Also, are Marketing Cloud and Commerce Cloud supported as well?
Yes. So we support Velocity completely. There is going to be a presentation tomorrow morning on Velocity. So I believe it's going to be at 8 a.m. Pacific on Velocity, where we'll just talk about Velocity in 10 minutes. And then we support all managed packages such as Salesforce CPQ, Encino, Aptus. We can support the migration of the metadata components, the extensions to the managed packages, as well as the data within the custom object of those managed packages. So let's say in Salesforce CPQ, we can migrate the entire hierarchy of data of all the data which is created in custom objects of Salesforce CPQ, and we can migrate the entire hierarchy.
Okay. And we have another question about Federamp and Flosum. Is Flosum Federamp certified?
Yes. So we work with a lot of government agencies. We are, I believe, we are at least in 6 to 8 different federal agencies. The way Flosum is created is that it's completely within your Salesforce org. Not a single byte of data or code will ever leave your Salesforce org. So because of the architecture of the Flosum application, um, FedRAMP certification is not required. We have worked extensively with a lot of architects within the Salesforce community, a lot of architects within the federal sector, and they feel Flosum does not need FedRAMP certification because it's secure and the nature of the Salesforce architecture itself. Because Salesforce is FedRAMP certified, Flosum doesn't need that.
Awesome. And this question is really about whether, or they're asking if Flosum provides any error resolution recommendations.
Yes. So whenever, let's say you have a deployment error, most of the time what we do is, as mentioned here, we can automatically fix your code issues, right? So let's say if you're deploying a layout and the layout refers to a custom field which is not existing in your target org, we will prompt you that if you click on a button, we'll automatically add that field so that your deployment of the layout will go through successfully. This is just one example. There are a lot of other issues that we fix automatically as part of a deployment. And this, what we see is when most customers, they are deploying Salesforce code, they make a deployment, it doesn't succeed. Let's say you're deploying 50 components, Salesforce will show 10 errors and then it'll stop. And then once you fix those 10 errors, again, if you do a deployment, Salesforce will show another 7 errors. And once you fix those 7 errors, then Salesforce will show another 20 errors. What we do is we scan through your entire code at once. We read the code. We know which target org we are going to deploy on. And then we find out all the code issues that will potentially happen if you try to deploy that package. And then we'll suggest that these are the problems that may happen when you deploy it. And we'll suggest that if you just click on the button, you'll automatically fix that code issue. So you reduce the number of retries that are happening because of deployments, and you don't have to look at different places. We'll automatically fix your code for deployments.
All right. And I think this is going to be our last question as we are nearing the end of our session. How long does it take to implement Flowsim?
The implementation is largely dependent on how fast you want to go. In terms of your basic value to improve deployment velocity, automatically fix the code, improve the quality of releases, you can get that done, literally in a couple of hours. If you're working with a customer success team, if you suggest, let's finish the whole implementation in 4 hours, that is also possible, including setting up, like, let's say if you have Git integration, if you have Jira integration, if you have ServiceNow or Azure DevOps integration, you can do all that in a very short amount of time.